Good morning, students. Today we are going to continue the last session, which is addressing modes. So, in the last class, we started the addressing modes, what exactly the addressing mode and all those things we define, and we have seen how many types of addressing modes are there in 806 and which are going to be supported by 806. So, here in the today's class, we are going to continue the last session. I think in the last session, we stopped at the direct addressing mode of operation. So, in the last session, we stopped at direct addressing mode of operation. So in this session, what we do is we'll continue the last session. So here, before continuing, so let us revise what exactly the addressing mode. So addressing modes means the number of ways that are used for representing the location of the data are called as an addressing modes. The number 806 microprocessor is supporting the following addressing modes which are there on the screen. One is the immediate addressing mode, register addressing mode, memory addressing mode. Under the memory addressing mode, again we are having the five types. One is the direct addressing mode, register and direct addressing mode, based addressing mode, indexed addressing mode, based indexed addressing mode, and the final one is a port addressing mode. Okay, now, so till now we have seen the immediate addressing mode, register addressing mode, direct addressing mode. So in the today's class, we are going to finish up the addressing mode by concluding the rest of the topics. Okay. So here, let us go for immediate addressing mode. We have seen one of the operand is a constant. That operand is always the source. That operand is always the source. And the next one is a register addressing mode. In this addressing mode, both the registers should be the both the operands should be the registers and both should be of same size. And also we have seen the rules and regulations. What kind of registers can be there at the destination position, all those things in the last class. And another one is the memory addressing mode. Under the memory addressing mode, direct addressing mode. Direct addressing mode is nothing but in any instruction, one of the operand is going to be uh, uh, the memory address. One of the operand is going to be the memory address. So we know that in case of the 8086 microprocessor, in 8085 microprocessor, we are having the memory address directly. But in case of the 8086 microprocessor, whatever the memory we are specifying in the as a part of the instruction, like this on the screen. So this one is showing the offset address, not the complete to 20-bit physical address. So 20-bit physical address format is nothing but we are supposed to have the base address followed by the offset address. But here we are having only the offset address. So offset address means if you are not having any means complete 20 physical address format, 20 physical address format, 20-bit physical address format is nothing but address which is represented using the base register content, that is a base address as well as the offset address. Base address followed by the offset address. But here we are having only the offset address. So this offset address, as we have seen that this one is belongs to the data segment. If you want to explicitly mention that to which means other than the data segment, if you want to access a particular segment, uh, memory location for reading or writing the data, then you are supposed to explicitly mention the what is that 20-bit physical address in the form of base address followed by the offset address. So as we know that base address of the each segment is there in the respective segment registers, and offset address is maybe there in the respective offset address. We have seen that combination also, like CS colon IP, SS colon SP or BP, DS colon SI, ES colon DI. Okay, like that we are having the offset address followed by the base address followed by the offset address. So in the last class we covered this topic, right? So in the today's class, what we do is we'll continue the session with the register indirect addressing mode of operation. So register indirect addressing mode of operation means one of the register contents. So in the previous case, directly we are mentioning the address of the location. Means a particular address to into which you would like to write the data or from which you would like to read the data. We are directly specifying the address. But in the register indirect addressing mode of operation, we are taking one of the register content as an address. We are taking one of the register content as an address. So in order to perform the register indirect addressing mode of operation, register indirect mode of operation, we are having the four registers. 806 microprocessor using the four registers. Out of four, two are the base registers, two are called as the base registers, and two are called as a index register. Two are called as a base register, two are called as a index register. Okay. So here means any one of these register content. Whenever you want to make use of one of these registers content as a address means which is showing the offset address. If you want to make use of one of the these register content as an offset address, then you are supposed to write the instruction using this syntax, just like this syntax. Okay. So this syntax, it says that if you see this one, for example, before this instruction, assume that I'm having one instruction with one instruction like move. I'll take the capitals here, so to speak. Move bx comma 9000 h bx comma 9000 h. So in this example, what I'm doing is these two are the my instruction in my program. Okay, these two are the instructions which are there in the sequential order. So here first instruction is a move bx comma 9000 h, means I loaded the bx content with the 9000 h data. Okay, so it is a data operation. Now what is the bx content right now? Bx content is a 9000 h, but I would like to make use of this particular bx content whose value is a 9000 h as an offset address. Then I'm going to use this instruction. I'm going to use this particular instruction. Okay, so this instruction says that load the uh, load ax equals, means ax is going to be loaded with the data available in the bx data available in the data segment. Data available in the data segment, because let me write the complete one, bx colon full space bx. Yes, bx. Okay, so this is what exactly happening in this instruction. Okay, so we loaded the bx as a 9000h. Now this particular 9000h is loaded as a data into the bx register. Now I am using this particular bx register content as an offset address over here. As an offset address over here means if any one of the base register or the index registers are used along with the square bracket, then they are specifying, means the register content, the respective register content is acting as a offset address. Is acting as a offset address. So that's why it is called as a register indirect addressing mode of operation. In register indirect addressing mode of operation is nothing but one of the register content is used as a offset address representation. Okay, it is used for representing the offset address of a so and so segment. Representing the offset address of a so and so segment. As you know that if we are not writing the complete 20-bit physical address format, then the default segment is a data segment which is going to be used by the microprocessor. So if you see the down one also same thing. But here it is belongs to the data segment. But in the down one we are specifying 20-bit physical address format. So bx content is used as a offset address in the extra segment. From there the data is going to be read and stored inside the AX register. Okay, it is going to be loaded into the AX register. So this is the register indirect addressing mode of operation. In 8086 microprocessor, in order to perform the register indirect addressing mode of operation, there are 4 registers available. Using the means 4 registers are available. 2 are the base registers and 2 are the index registers. Using any one of those registers as a part of the instruction with the square bracket means you are using the register content as an offset address. Register content as an offset address. Okay. So that is what we are having, the register indirect addressing mode of operation. Register indirect addressing mode of operation. When you are taking the register indirect addressing mode of operation, or otherwise, if any one of these registers are specified in the instruction, in a particular instruction with a square bracket, then obviously the content of this register is specifying the address. The content of this register is specifying the address. It is specifying the address. Okay, so this is the register indirect addressing mode of operation. Now based on which registers we are using, whether we are using the base registers to represent the address of the so and so memory location, or whether we are using the index register, depending on that, again these register indirect addressing mode of register indirect addressing modes uh, are of two types. Again, are of two types. Two, not only the two, it is going to be the three. Okay, now that means what we classified over here. So these are then a base addressing mode, index addressing mode, base index addressing mode, and register indirect addressing mode. In my point of view, register indirect addressing mode, if you realize this one, then the rest of three are very easy, because in the register indirect addressing mode is nothing but one of the register content is used as a address, means without specifying the address of a memory location directly as a part of the instruction, we are taking the one of the register content to represent the offset address of a memory location, offset address of a particular memory location in a particular segment register, in a segment block, in a particular segment block. Okay. So here, as I said, register indirect addressing mode supported by the 4 registers. Now, if only these two registers are used, then we have one more register address, one more addressing mode called as a based addressing mode. Based addressing mode is nothing but it is also register indirect addressing mode only. But in this register indirect addressing mode, what we are doing is we are not going to use the index registers like source index register, destination index register. We are going to use only the BP and the BX. That is nothing but the base registers. Base, we are going to use only the base registers. Okay. So means over here we are using the base registers only. So the base registers are nothing but what? BX. Base registers are the BX and BP. We are going to use BX or the BP to represent the address of a so-and-so memory location. Okay. So here this is the base addressing mode. Now. So this one is going to be the base addressing mode. Okay. Base addressing mode. Okay. So example is if you see this one, there is a slight difference between the last register indirect addressing mode and in this register indirect addressing mode. So here if you see this one in the last example, last addressing mode example, we took the move ax comma square bracket bx. But here we are having one more element called as a D8. D8 is nothing but the 8-bit displacement. 8-bit displacement. This kind of addressing mode majorly used the displacement value. Why we are using the displacement value means this kind of displacement value is going to be used in accessing the array of elements. Okay. All of you know what exactly the array. Okay. So what exactly the array in C programming. Similar to that, here also we are having the arrays. Okay. In order to access the element which is a part of the array, then we are going to make use of the based addressing mode or the indexed addressing mode, and in that case we are having the 8-bit displacement value. 8-bit displacement value means how far it is there from the starting of that particular array. Array is nothing but similar data elements which are stored in the continuous memory location. Similar data elements which are stored in the continuous memory location. So if you have remembered that one, I think in the C program, let us suppose I am declaring one variable called as a to hold the what we say to hold array of elements. Then I am going to specify like this: a of 6 clone. What exactly is this meaning? I am having an array whose type is an integer type and which is able to hold the 6 variables, 6 values. Okay, now whose size or whose dimension? Whose dimension? If you are going more specific way, it is called as a dimension. Whose the array dimension is going to be the 6. Means it is having the capability to hold the 6 types, 6 integer values. 6 integer values. They are in the continuous memory locations. They are in the continuous memory locations. So this value, whatever the value we are seeing, this value is called as a displacement value. So here it is a displacement value. Here it is a displacement value. Means when you are trying to access the array of elements which are stored in a segment in the continuous memory location, then we are going to make use of the displacement value. That displacement value may be the 8-bit value, or the displacement value may be the that displacement value may be the 16-bit value. The displacement value may be the 8-bit value, or the displacement value may be the say what is that 16-bit value. Okay. So let me show you one example. So here we are having the what we say this example now, move x comma d8 of bx. So assume that the bx content is a 9000. I am going to fix that one as a 9000 throughout the session. So bx content is a 9000h. Now after executing this instruction, what is happening is a question. So soon after the microprocessor executes this instruction. How exactly the microprocessor is going to be executes this instruction is a question. So in this case, AX is going to be loaded with a value, called as loaded with a value which is a DS colon, because here we are not having the specific one. So we are not having the any specific what is that segment. So default segment is nothing but the data segment only. So that's why I took the DS. Okay, data segment only. That's why I took the DS colon. So whatever the 8-bit value you are mentioning over here now, that 8-bit value is added with the content of the BX. This 8-bit value is added with the content of the BX. So assume that, for example, instead of taking this one, what I'll do is I'll go for another way of explanation. Yeah, I'll take one example instruction. So this is the syntax, and I'm going to take one example instruction. So here I'm assuming the BX is a 9000. Okay, no, 9000 H memory location. That is a 9000. Okay, no. So let me take this one. The example. So this example is nothing but it is going to be yeah. Okay, wait. Move, move, ax comma ax comma 04h or otherwise 06h, whatever the value you want you can take of bx of bx. So what is happening over here is the question. So if I'm having the statement like this, so how exactly this statement is going to be realized by the microprocessor and executes this instruction is a question. So in simple format, I can say that this instruction is trying to copy the 16-bit number from the memory location specified by this particular part. From the memory location specified by this particular part. So this entire thing is specifying the memory location which is there in the data segment, and that value is going to be stored inside the AX register. Okay. So what I mean to say that, let me show you the what exactly happening in the above instruction. So AX is going to be filled with the DS colon filled with the data specified by the address, which is nothing but the BX is how much ma? BX plus, I'll rewrite one more time, BX plus how much? What is the displacement value? 06 we took na? 06H. Okay. So now AX equals to DS colon BX content is how much? We assumed it as a 9000H. 9000H plus 06H. Again, AX equals to DS colon 9006H plus 06H is nothing but 9006H. Okay, so means now whatever the value which is there in the data segment whose offset address is a 9006H, that value is going to be stored inside the AX register. That value is going to be stored inside the AX register. So this is the meaning of this particular instruction. So means D8 is specifying the displacement value. D8 is specifying the displacement value. I think I thought that I'm going to finish off the addressing modes over here, but I'm expecting that you do not get this one. So let me show you one simple one. Simple one. Wait a minute. I'm not satisfied with this explanation because here you are trying to, as I said, you are trying to access when a array of elements are stored in the consecutive memory location. You are trying to access a particular element in that particular array. A particular element in that particular array. So if you realize that one, don't no problem at all. But if you are not realizing, then I have to do some other explanation. That is nothing but, so in another way, yeah, I'll give the another way of explanation. So here we are having the one array whose starting address is a 9000H. Whose starting address is a 9000H. Assume that our array is a 10 elements array. Now I would like to access the sixth element in that particular array. Then I'm writing this particular sixth element as a displacement value over here. As a displacement value over here. Okay. Now, so in that particular array, I'm going to access the if it is a 9000, it is going to be the seventh one. Okay. Forget about the figure, but this one is the displacement value, and this displacement value is added to the starting address of your array, and whatever the result you are getting as a 9006H, that is going to be forms the entire offset address available in the data segment, and that value is going to be stored inside the AX register. That value is going to be stored inside the AX register. Okay. So if you want, I'll take one simple example. Okay. I'll come to this one. Okay. Mm, is it necessary? It is necessary. No problem. 9000H plus 9001H plus, sorry, means I'm just writing the memory locations 9001H, 9002H, 9003H, 900 4H 900 5H 900 6H and so on and so on. Okay, so these are the continuous memory locations. Assume that this is my array. So assume that my first array element means I'm having one array. It is able to hold the seven values, seven similar data elements. So let us suppose it is a bad value. So means my array is able to hold the seven values which are there in the continuous memory location. But the starting address of my array is what ma 9000. I'm assuming that that starting address is there in the BX register. That starting address is there in the BX register. Okay. So now it is showing the static address of our array. Na? I would like to access this is the starting address, but we know that this is the length of my array. This is the length of my array. How many elements are there? It is started with the 9000, ended with the 9006H, means total 7 are there. So this is the starting address of our array. But in this particular array of elements, I would like to access the fifth element. I would like to access the fifth element. Okay, I would like to access the fifth element. So this is the fifth element. Na? Okay, so if you see this one in this array, this is the fifth element. Na? How far it is there, ma? It is there 1, 2, 3, means 0 is already there. So I would like to access the fourth element. Na? So it is going to be the 1, 2, 3, 4. So from the starting address, from the BX, it is 04H this away from the starting address of my array. Starting address of my array is a 9000H, and my element which I would like to access, it is away from the 4 memory locations. After the base, it is going to be away from the 4 memory locations. So now I am going to take this one as a displacement value. In simple short means I would like to access this one. In the array of elements, I would like to access the 9004. So I am going to write the instruction like this: move space ax comma. What is the displacement? 4, right? 04H 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 colon dx colon dx. That's it. Okay, colon dx. So in this case, what is happening? In simple short, ax equals to ax is going to be filled with ds colon uh, bx plus 04H. But we know the bx value is ax equals to ds colon bx value is how much? Bx value is 9000H H plus 04H. Enter. So finally it is going to be the ax equals to the how much? Ax equals to the ds colon 9004H. So here in this case ax is loaded with the memory content specified by the offset address 9004H. So this offset address is nothing but the displacement value within this particular array. Displacement value within this particular array. So this is all about how exactly that means when we are going to use the based addressing mode and the indexed addressing mode, all those things means when we are having the array of elements, and if you want to access that particular array of elements, at that time we are going to use the based addressing mode as well as the indexed addressing mode. Based addressing mode as well as the indexed addressing mode. Okay now. So in this example, 8-bit displacement value is added with the bx content, and finally it is forming the offset address. From that particular offset address in the data segment, the value is going to be stored inside the AX register. So here instead of the 8-bit content, we are going to have the 16-bit. 16-bit displacement value is added with the BX, and result of that one is specifying the what is that offset address. That offset address is belongs to the data segment, and from there the data is going to be stored inside the AX register. Okay, now, so this is what we are having in simple case. Yeah, this is what we are having in what is that based addressing mode. In a based addressing mode. Okay, wait, I forgot to remember the time because it is going to extend more. Okay. So it is going to be the based addressing mode. Next one is the indexed addressing mode. So just like the based addressing mode, here also same thing, but instead of having the or instead of using the base registers, we are going to use the index register. We are going to use the index register. Here also the offset address is going to be calculated by adding the 8-bit displacement value with the content of the source index register or with the content of the destination index register. and result of that particular addition is showing the offset address. That offset address belongs to the data segment if at all we are not specifying the explicit one. For example, I'm going to rewrite the same instruction. I'm going to rewrite this. Oops. Okay, I'm going to rewrite the same instruction. Base addressing mode is over. I think hang up maybe. Wait, yeah. Here I'm going to write the same instruction in another way. Move, mm, move ax comma, sorry, ax comma, mm, yes, ds, sorry, es colon uh, d8, is a d8 displacement 8-bit displacement value with the dx register. Sorry, we are taking the index registers, right? So let us take the SI. SI. So the difference between these two. So let me take that too. Yeah. Difference between these two instructions is here we are not having the 20-bit physical address format. Here we are not having the 20-bit physical address format. So because of that, this offset address, after adding the 8-bit value with the SI content, whatever the result you are getting, this offset address belongs to the data segment. But here we are explicitly mentioned from which segment, means this one is going to be calculated as an offset address. This offset address belongs to the extra segment, and from there the value is going to be read and stored inside the X register. Okay, now difference between these two is here it is a data segment, here it is a extra segment. That's what I would like to inform. Means differentiate the instruction, because every time I'm using the same instruction as an example, but we are having the one more thing, means when you would like to read the information from the extra segment other than the data segment, then this is the syntax. Okay, so the next one is the next type of addressing mode is a, we have seen the based addressing mode, we have seen the indexed addressing mode, right? Next one is a based indexed addressing mode. Based indexed addressing mode. Okay, now so in the based indexed addressing mode, the content of the 8-bit displacement value is added with the bx content, and that bx content value is again added with the si content. After adding the si content, bx content, 8-bit content, whatever the result you are getting, that is going to be from the offset address to the corresponding segment block. Okay, now so here as we don't have any segment register, so that's why this particular offset address belongs to the data segment. This particular offset address belongs to the data segment. So if you want the explanation for this instruction, I'll take a simple one. Means I'm going to oops, sorry, I'm going to sorry. Yeah. What I'll do is I'll take the explanation how exactly the this instruction is getting executed. Mm, I'm just rewriting move ax comma uh, d8 of bx of si. That's it. So what exactly this meaning is, ax is going to be filled with the ds segment. Offset address is calculated by using what? By adding the d8 value, d8 displacement value with the bx content and also with the si content. So after adding the content of the si, bx, d8, whatever the result we are getting, that result is going to be forming the offset address. That offset address is acting as an offset address of the data segment, and from there the value is going to be loaded into the AX register. From there the value is going to be loaded with the AX register. For example, I am assuming that we fixed the BX value, BX value as a 9000. Sorry, we fixed the BX value as a 9000H. Let me fix this. What is that? SI value. SI value as a 04400H value. SI equals to the 0. I'm not taking big numbers because you may get confused. Here I may take the other number 100, all those things, but I don't know how many of you are going to realize that one. So as it is a startup class, I'm going to take a simple value 04000H. Okay, and assume that D8 value. D8 value, I'm just assuming the 8-bit number is equals to the some 09H. Then what will happen? So X is filled with what? X is going to be filled with AX is going to be filled with DS colon D8 is how much, ma? That is the displacement 8-bit value. 8-bit displacement value is how much? 0909 H plus what is the BX value? 9300 H plus what is the SI value? 0400 H. Okay, 0400 H. I think it is going to cover. My photograph is going to cover that one. Yeah, it is going to be the 0400 H. Okay. Finally, AX is equals to the DS colon. If you add that one, you are going to get the 9404 H. Do the manual, uh, do the mathematical addition operation, simple mathematical addition operation. So 9409 H memory location. So this is what means by adding these three elements of registers content, we are forming the what we say we are forming the complete offset address. This one type is added, this entire is added. So final offset address which is going to be used in this particular instruction is the 9409H. Okay, so this is all about the based index addressing mode of operation. Based index addressing mode of operation. Okay, so in memory addressing modes, let us go back a while. In memory addressing mode, we are having the direct addressing mode. Direct addressing mode means one of the operand is specifying the memory location directly as a part of the instruction. Means in any instruction, if we are having one of the operand position as a numerical value with a square bracket, then it is going to be the direct addressing mode. Okay. If you are having the numerical value without square bracket, then it is a constant, not the address. Okay. So in the register and direct addressing mode, in the direct addressing mode, we are directly specifying the address of the memory location. But in the register and direct addressing mode, we are taking one of the register content as a address, as an address. Okay. So those registers are nothing but the base registers as well as the index registers. So I think energy is not sufficient to me. I'm not feeling well, ma. So okay, wait. Base addressing mode. Yeah, register and direct addressing mode. We have seen base addressing mode is nothing but we are having the we are taking the content of the base registers as a um, content of the base register to mention the offset address. The next one is the index registers, and both combinedly it is a base index addressing mode. Okay. The next one is a port addressing mode. What I'll do is I'll explain the port addressing mode in the next coming class now because something is disturbed. Okay. We are having the port addressing mode. We'll continue in the next session about the port addressing mode. And after that, we'll start the instruction set. Okay. Thank you. If you are having any doubts regarding this topic, then just let me know in the WhatsApp group. Okay. Thank you. That's all for today's class.